Very good morning, students. This is Unit 1 in COA. This is our second topic, register transfer and micro operations. What is register transfer and micro operations? First, the content of the unit. The second topic is register transfer language and register transfer, bus and memory transfer, arithmetic micro operations, logic micro operations, shift micro operations, arithmetic logic, shift unit. So these are all the content by the topic register transfer language and register transfers. First, what is register transfer language? In digital system, in a digital system, every modules are defined by set of registers. What is a modules are defined by a set of registers, and one more point is there, the operations that are performed on binary information stored in them. You already know that in a digital system the operations can be done on binary information. The binary information can be stored, or the module can be stored in a set of registers. That is the point. Whatever you want to make or to perform the operation, first you need a set of registers. That is, module can be designed as set of registers. Okay, so that is the point. The next, micro operations. Operations can be done on a set of registers, or the operations are executed on data stored in registers, because the data are stored in a registers. That's why the micro operation can be done on data stored in registers. Next, result of operations. The data can be replaced in registers. Data can be replaced in registers or transfer it to another registers, that is register to register, register to memory, or within registers. This is the meaning of result of operation. Suppose we have to done one operation. After completing the operation, the result will be stored again in register, or the register or the registers, the result of data will be transferred on memory. So this is the transfer we have to done using data transfer language. The next one, examples of micro operations. What are the micro operations? That is for shift, count, clear, and load. So load the register, clear the register, count register, shift one register to another, register to memory, memory to register, likewise. So these are all the some micro operations we have to done in register transfer language. Go to next. Here the detailed explanation of register transfer language. In a digital system, you have to define three categories. First one is set of registers, second one operations, then third one control and supervise the sequence of operations in a system. So this is the main task of every digital system. What is first, in a digital system it contains a register, then second points, operations are performed. How it is performed, the data stored in registers. And third point is it control and supervise all the sequence of operations. This is the meaning of digital system. Okay, the next, register transfer operations. Register transfer operations. Every information, that is the information flow and the operations, that is the processing performed on data stored in the register. Yes, already I told you, informations and processing operations on the data stored in the register. Only the data are stored in registers. Based on the register data stored in register, we have to perform the operations and the information flow, transfer the informations within register to register, or whatever the register to memory. Then register transfer language, RTL. In the register transfer language, every register has symbolic notation, that is register specified as R, that is a symbolic notation to describe the micro operations. Okay, every instruction has a micro, that is a single line will complete one operation. That's why the register transfer language are considered as micro operation, transfer among registers. Okay, go to next. Why register transfer language? We take why register transfer languages, that is in register transfer language is a symbolic language. Already I told you, in a register transfer language as a symbolic language, user convenient tool for describing the internal organization of digital computers, and can also be used to facilitate the design process of digital system. So that's why I'm taking the register transfer language. What is symbolic language? For convenient tool. So there is a reason for take register transfer language. So this is a register, common representation of register for R1. So R is a symbolic representation of register in a capital letters. Okay, and then MER is a register, that is a memory address register. M for memory, A for address register. So R1 is a processor register. There are two registers are there, memory address register, then R1 register is a processor register. Okay, this is the representation of register. Okay, next. There are two types of register. One is 8-bit register, another one is a 16-bit register. R, the register is a group of flip-flops, that is the individual flip-flops in n-bit register are numbered in sequence from 0 to n minus 1. 0 to n minus 1. Okay, that is 0 to 7 is 8-bit. The group of 8 bits will stored in one register, that is R1 or R2 or R3, whatever the symbolic representation, the name is there, it will be stored some datas. Okay, a bit of data can be stored in a one flip-flop. So group of flip-flops is considered as a register, that is the n bit is considered as a register. Okay, the next numbering of bits in 16-bit register. The second one is a 16-bit register, which is ranging 0 to 15. Totally 16 bits are there. The 16 bits can be represented as two parts. One is lower order, that is PCL for low byte, PC of H for high byte. Considerably in a 16-bit register, the other name is called program counter. The program counter is separated by low byte and high byte. So low byte is nothing but 0 to 7, first 8, then another 8 for 8 to 15 is a high byte. Okay, that is the meaning is that bit 0 to 7 are low byte, bit 8 to 15 are high byte for H and L. Okay, this is register transfer. Next, one example is that the information is transferred from one register to another, that is register 1 to register 2. The arrow mark is represented to register 2. The content of R1 is assigned to R2. Content of R1 is assigned to R2, that is the transfer of the content of R1 into register R2. That is the meaning. Move one place to another place. Okay, here the content of R2 content will be replaced by R1 content. That is the meaning. The arrow mark is presented in R2. Okay. One more point is there, R1 content will not be changed, only the R2 content will be replaced for R1. Okay, So next, one another example for register transfer. In the previous statements, if p equal to 1, then it make or it sure to transfer the content of R1 to R2. Okay, where p is a control signal. Here in the next, the control signal, it implies this is the structure of hardware structure of transferring the content of R1 to R2. First R1 to R1 transfer content of R1 is transferred to R2, whether it interfacing clock cycle and control signals, that is a control unit for P. Both the control unit and clock cycle will represent in R2, that is equal to 1. It indicates equal to 1. The data transfer is done, otherwise it could not transfer the data. Okay, this is the logic of the clock cycle becomes high. When the clock cycle becomes high, the control unit is uh, supervise the transfer of data. Okay, next, so this is the clock cycle and control units, that is a load. First one is a clock for low and high, low and high, low and high. When the data transfer is done, the second line is there, that is load. The data transfer is done, that is transfer occurs here. The arrow mark is there. This is the timing diagram for transferring content of R1 to R2. Next, another example 2. Suppose we have to include more than one register by using comma. It is a comma separate two or more operations. One operation is R1 content of R1 to R2. Another operation is content of R2 to R1. There are two operations by separated by comma. Okay. So one comma, that is one operation will be done on the clock pulse provided t equal to 1, that is the timing diagram. So another operations will be done another clock cycle. So you can add more than operations by increasing the clock pulse. So this is basic symbols for register transfer, symbol and description and examples. So first MER comma R2. So memory MER is a memory address register. Then R2 is a process register. These two are called a register. The symbol is represented as letters and numerals. The next parenthesis. So parenthesis, what is the use of parenthesis? It denotes part of a register. Suppose we have to define lower order as well as the higher order to separate them. That is a lower order for R2 0 to 7. That is a lower order, or you can specify R2 of L. So L means it is a lower order bit 0 to 7, or you specified the bits also 0 to 7. The next arrow is denotes transfer of information. So where to transfer the data, that is register 1, the content of register 1 is transferred to content the register 2, that is assign the data in register 2. Okay, well, that is the purpose of arrow. Then comma to separate two micro operations. Oh, you can add one or more micro operation, you separate by using comma. So this is the symbolic of data transfer, sorry, register transfer language. Okay, so this is the register transfer language. Next we shall discuss about micro operations. Keep watching video. The next class will take micro operations. Okay, thank you students.